In today's lesson, we are going to be looking at quadratic models using the vertex form. So it's going to be a little bit of review of what we've looked at, not in our last unit, but the previous unit before that. So we've looked at quadratics, we've looked at how to factor quadratics, and now we're going to look at sort of problem solving and finding specific values of a quadratic given different forms now that we know how to kind of convert between them. We are going to learn some new methods of converting between different forms as well. That will be kind of some new steps that we haven't touched on, but it will be important in finding some key information. Because the different types of quadratic expressions have different useful pieces of information in them that allow us to kind of find out different things about our quadratic or our parabola. So we're going to be reviewing the vertex form. So again, the vertex form is y equals a x minus h squared plus k. Our a value tells us the step pattern. Right, the general pattern, the basic pattern is 1, 3, 5. But in general, if we're dealing with our step pattern, we could call it as 1a, 3a, 5a, because we multiply that basic step pattern by the a value when we change it. The a value does tell us whether it opens up or down. So it opens up if it's positive, or opens down if the value itself is negative. It does tell us a stretch. If a is greater than 1, it's a stretch, or it's a compression. Or if it's a compression, if a is between 0 and 1, so greater than 0, but less than 1. Or we can say it's neither if a equals 1. So if a is 1, it's neither. There's no stretch or compression. If a is greater than 1, there is a stretch. If it's between 0 and 1, then there's a compression. Step pattern opens up or down, stretch or compression. I believe that is all that our a value tells us. The step or the h value. The h value tells us the axis of symmetry. That's that middle value, axis of symmetry. It does tell us the x value of our vertex. And it tells us a horizontal shift. Left if it's positive, left if it's negative. Left if it's negative. Right if it's positive. And one thing we need to note for the h value, it's opposite, or the opposite sign of what we see. Our k value tells us the max or minimum, tells us the y value of the vertex. It tells us our vertical shift. It goes up if it's positive, and down if it's negative. So it tells us how our graph shifts. So each of these values has some specific information about our quadratic, about our parabola, about some of the key values, and also tells us a lot about its transformation, how it's changed. So again, that should be reviewed from our previous units. So the first thing we want to do is just kind of remember and just identify key pieces of our information or of our quadratic that will help us identify the different graphs based on the equations. So we have 4 equations and we have 4 graphs and we want to match them. So looking at our 4 graphs, a key difference, or one thing that singles the other ones or one out, is the first one. This opens down. So this one's opens down. So without even looking at anything else, right, there's only one equation that has a negative a value, and that would be c. So because c is the only one that has a negative a value, that means that this one here has to be c. It's the only one that opens down. Now, that crosses off c. Now I'm left with 2 other ones. So I can take a look and see, okay, what information is given to me in my 3 equations. Well, 2 have similar things, right? 2 have -8. So 2 have ones that are moved down, right? So I have a -8 and a -8. So this is my k value and my k value. So those 2 values tell us that our graph has shifted down. So if I look at my 3 remaining graphs, if I put a point at their vertex, and let's put a point at the origin for a reference, there's only 2 graphs that have moved down. And that would be number 2 and number 3. So both of those have moved down 8. So that means that B would have to be number 4. Being the reason is that it hasn't shifted down. Now you could also say if I look at the H value, the H value is -3, opposite of what we see, and we've shifted to the left 3 units. So that means that number 4 has to be 3, or B, sorry. Now between our 2 remaining ones, A and D, again, looking at them, okay, what's the difference between them? Well, one has an H value, the other one has an A value. D has an H value, so that means there is going to be a shift left or right. The only one that is shifted left or right is number 2. That means D has to be number 2, and that leaves A with number 3. And the other thing you could look at and say, well, another difference is that 2 has an A value, or sorry, not 2. Equation A has an A value of 2. That means it's going to be skinnier or stretched compared to equation D. So if I look at the 2 graphs between number 2 and number 3, that were my 2 leftover ones, number 3 definitely looks like the one that is skinnier or stretched compared to D. So that's another way that we could have differentiated between the 2. But again, it's just about reasoning based off of the different equations that we are given. Example 2, the equation or the vertex of a quadratic relation is 4, -2. We want to come up with an equation to describe all parabolas with this vertex. So let's going to write out our vertex, 4, -12. I might have said -2, but I meant -12. Now, if I want to write an equation for this parabola, for this quadratic, because I'm given the vertex, I should be using the vertex form. So y equals a x minus h squared plus k. If I was given something else, if I was given the x-intercepts, I might use a different form. However, because I'm given vertex, I want to use vertex form. Now, because I'm writing an equation to represent all parabolas with this vertex, that means all I'm going to fill out is my h, which will be -4, and my k, which would be -12. I'm not filling in the a value in this case, so my answer is going to be y equals a times x minus 4 squared minus 12. And this is going to represent all parabolas with a vertex of 4, negative 12. So any parabola that has this vertex is going to have this form or this general equation. Now the specifics come in with something like b. Now for b, we're told that it passes through a specific point, 13, 15. Now that means it's not going to be just any equation. It's going to be a specific equation. And what we have to do is we have to determine the value of a for this parabola. And we've dealt with this before in our previous lessons in some word problems. So because I'm given a point, which is 13, 15, or basically an x and a y value, I can sub this into the equation. Y equals a x minus 4 squared minus 12. This 13 is going to sub in for x because that is my x value. And this 15 is going to sub in for y because it's my y value. So I have 15 equals a times 13 minus 4 squared minus 12. And now I'm just going to rearrange this equation and solve for a so I can come up with my actual specific equation. So I can simplify within the brackets. 13 minus 4 is 9, so 9 squared, a times 9 squared minus 12. I'm going to move the 12 over by adding 12 to one side, adding 12 to the other. So I get 27 is equal to a times, and I can do the 9 squared, which will be 81. Now one thing to keep in mind, it's a times 81. It's not a plus 81 or a minus 81. It's a times 81. So in this case, I have to divide to cancel it out. I'm going to divide both sides by 81. And I get a is equal to 27 over 81, which would reduce to, I believe, 3 over 9 or 1/3. Check on my calculator. Yes, it does reduce to 1/3. So now this means that my equation is going to be y equals 1 over 3x, or sorry, 1 over 3, not x, 1 over 3 times x minus 4 squared minus 12. And this is going to be my specific equation for this parabola that has a vertex of 4, negative 12. And passes through the point 13, 15. So now this is a very specific equation. The last question is asking, okay, what transformations are made to the graph of y equals x squared to obtain our new equation? So I have to look at my a, h, and k and figure out, okay, what transformations have occurred? Well, if a value is 1/3, then that means we have a compression. Compression, it also is positive, so it opens up. Our h value is 4, or the opposite of what we see, so that means we have a shift right, and we can be specific, shift right 4 units. And our k value is negative 12, so that means we shift down. Units. So based off of that a, h, and k, I can now determine what the transformations are or how this equation has changed based off of my basic or original function of y equals x squared. So we're going to do the same thing, 2 other examples. We have a graph now, we have a vertex, in this case 0, 0, and we have a point with an x and a y. So I'm going to use this information. I'm going to write out my vertex form equation. So y equals a x minus h squared plus k. I'm going to plug in my h and k, in this case from the vertex. It's going to be x minus 0 squared plus 0. So this makes it a really easy one to solve. So I have y equals a x squared. I'm going to plug in my x and y from my point, so the point 2, 1. So I'm going to have 1 is equal to a times 2 squared. I'm now going to write out, I'm going to solve for a. So 1 equals a times 4, or 2 squared, which is 4. Divide both sides by 4. So divide both sides by 4. One side will cancel out. And we're left with 1 over 4 equals a. Now I have my a value. I have my equation. I can add that in. So y equals 1 over 4 times x squared, or I can just say 1 over 4 x squared, or if I really wanted to, x squared divided by 4. Different ways you can write it. I'm just going to leave it as 1 over 4 times x squared, just so it keeps some similarities of that vertex form just for reference. But that is my equation for this parabola. If we take a look at it, we can see our vertex hasn't moved. It's still at 0, 0, so there's no shift left or right, and there's no shift up or down. There's also, we can see that it does appear to be wider, so that means our a value would have to be a decimal, which would work in this case, because we do have our fraction for our a value, or 0.25. One last example. Again, same idea. We're given a graph, we're given a point, or a vertex and a point. So our vertex here is 2 and 4. We're given a point, 3 and 1. So I can write out my vertex form because I am given my vertex. So that's when I have to come up with an equation, I should be using vertex form. So y is equal to a, which I don't know yet, x, which I don't know yet for my general equation, or we don't really fill in anything for x anyways, minus 2, opposite of what we see, plus 4. Now that I have my general equation with this vertex, I'm going to make it specific by plugging in the point 3, 1. So if I plug in the point 3, 1, y is equal to, or not y anymore, it would be 1 is equal to a times 3 minus 2 squared plus 4. I'm going to bring the 4 over by subtracting 4 from both sides. I get negative 3 is equal to a times 3 minus 2, which is 1, and then squared. I get negative 3 equals a times 1, or just negative 3 equals a. I don't need to divide by 1. It's not really going to change anything. Now I have my a value. So now I can plug this into my equation. Y equals negative 3 x minus 2 squared plus 4. And that's going to be the equation to represent this quadratic, or this parabola. And if we just take a look at the values, right, negative 3 for my a value, so it should be flipped and compressed, or opening down and compressed, which it does appear to be. It's definitely opening down. It does appear to be skinnier than some of our other parabolas. It should be shifted to the right 2 and up 4, which we can see from the vertex it is as well. So again, we should be able to determine the equation of a parabola given the vertex and a point. So a lot of this was review again from our units 2 units ago. So again, make sure you are familiar with some of these concepts. Make sure you are reviewing if you do find yourself struggling with this a bit. Go back, review the lessons from our first quadratics unit where we did look at vertex form. We did look at some of the transformations. We did look at determining the a value. So again, make sure you are going back and reviewing those lessons if you found some of this to be a little bit of a struggle.